Thanks, Phil, for the taking part in the Proof for Proof challenge. And again, this is the second one from me. Second.
3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It really is.
Level.
It really is.
Level.
And bam, there's the radius of the Earth.
Phil didn't like the triangles proof for some reason. You can check them out. We'll put them all together in a series at the end of this. Phil just chose what we call Proposition 16. A strange choice for someone like Phil, but I thought he understood the geometry, but maybe not. We'll get back to that at the end anyway. My new one today, I'm no good at that over there. Number 12, Proposition 12. I say thanks again, Phil, and long may this continue. I think we're going to, he said something about going live together to do these presentations of this geometry. So, I'll go. I'll just nip over to the board. Okay. This is proposition, as it says, states up here. Up there. Can you guys see that or not? Let me get this.
I can't read the proposition, but I can see the board.
I've got proposition 12 here on the TV.
Yeah, everything else is clear.
Basically, it states you've got to draw a straight line perpendicular to a given straight line. We'll mark this AB. A. B. Can you see that? That's not really very good either, is it?
Go a different color.
Oh, look at that.
There you go.
Oh. AB.
Popping.
To draw a straight line perpendicular to a given straight line of an unlimited length. So this line is unlimited. Then from a given point without it. This line at any point on here would be within the line. This would be without it. So what we have to do is to draw a perpendicular from this point straight down to this line of unlimited length. So it states, let AB be the given straight line which may be produced at any length both ways, and let C be the given point. Did I mark that? I didn't mark that. Let C up there be the given point with a straight line perpendicular to AB. So we need to make a perpendicular from there. Like it says, states there. We go compass. Extend the compass longer than the line to make a point down here. And extend the arc. And I'll put these ones here while I'm here. Compass isn't really meant for these boards. I've had to modify it. So we made an arc. We've made a point D. Is it D down here? D, and then we've extended a line from E to F and G. Is that right? I think so. So we've got a point there, and we've extended this arc of equal distance from here all the way around, intersected this line here and here at F and G. What we do is we purple one. We now join these lines up. To make an angle that we need bisecting. So we've got this angle, we need to bisect it now to drop it down there. So we take these points, I did it earlier with the compass, and we mark it at another point down there. Can you not see that?
I can't see below D.
You can see it.
Not down there, you can't see that. There you go.
There you go. It's down here. So what we do is we make... Hey, hold on. It's not long enough. Anyway, we do that, and we make these arcs down here again so that we can put a line from there, what's it called on the board? H. To this point here. H. I should have done it in the other pen. H. So that's perpendicular. How do we prove it? Professor Phil likes to have proofs. So the proof is that this line being both radius to that, this line is equal to this line. Therefore this angle is there, so this is equal to this. This angle is equal to this angle, all the same. So therefore this angle has been bisected, and this is 180 degrees split there. That's a right line. Perpendicular
Excellent.
has been dropped.
Excellent.
So there's your proof for dropping perpendicular onto a straight line. Proposition 12. Wherefore a perpendicular CH, what's it say? CH has been drawn to the given straight line AB from a given point C without it. Nice little proof for proof. Thank you very much, Phil.
Yeah, I was listening on the side there, and it's the most boringest show I'd ever fucking listened to until I turned up, funnily enough, and educated you all. Crazy, isn't it? I'm probably the thickest one here, and I have to educate you all. Water does not follow the shape of the container or the floor that it's on. Water flows until it reaches its own fucking level. Doesn't follow a fucking curve. If the earth is dropping, it would run off. Doesn't follow a fucking curve. If the earth is dropping, it would run off. End of story. That's where water's going. I'm not actually talking to these in here because I think these are too far gone. There are people that you just cannot recover. You've got to give up on them. I'm talking to your audience on YouTube. I want everybody on YouTube to understand my passion. I am not indoctrinated. I've rid myself of all that nonsense, and now I look around me and judge by what I see around me. And what I see around me is any test of water is flat when undisturbed or unaffected by another force. Doesn't follow a fucking curve. It lies flat, and that is what it is. Earth is not flat. We know it's not flat because we have mountains, valleys, and trenches at the bottom of the oceans. Whatever it is we're living on is undulating. But what water does, it shows us that there is no curvature drop. Doesn't follow a fucking curve. So I do not know what we're living on, but I know what we're not living on. Water would not do what it does on a ball. Now you all want to ask yourself, honestly, if you are honest and not paid shills like some of these, ask yourself honestly this question. I had to, and it was very painful, and I can help wherever I can, but it is painful because we've all been indoctrinated with this nonsense. Bev on Try Thinking is exactly right. We all have the same horizontal and we all have the same vertical. Whatever it is we're living on, it is generally a flat plane. But Earth isn't flat. Earth undulates. Peace, man.